In this video, you're going to learn how to create and structure a complete machine learning project, including the steps of building a dataset, creating features, then training a model, running some hyperparameter tuning, and then deploying the model and serving predictions via REST API. So this is the final product, and this is the REST API for body fat prediction API, and you can try it out here. We are going to be putting some features such as hip measurements, abdomen measurements, age, weight, height, and sex of the participant. And then you're going to get some body fat predictions based on the features. Hey everyone, my name is Venerin, and in this video we're going to have a look at how you can build your own machine learning project and how you can properly structure it. We're going to be using tools such as Poetry for dependency management and DVC to track our artifacts such as models, datasets, and preprocessors. Finally, we are going to be using DVC Live to track our experiments and do some hyperparameter tuning as well. And we are going to wrap everything within a REST API using FastAPI. We're going to build a project that is using some features in order to predict body fat percentage based on the features provided, and we are going to build a nice REST API along that. Let's get started. If you want to follow along, there is a complete text tutorial that is available for MLExpert Pro subscribers within the MLExpert Bootcamp. And here you can find Architect Your ML Project. Here you can find the complete text tutorial along with the structure and a nice explanation of each of the parts and each of the steps that we are doing along with the complete source code. And of course, all of the rest of the bootcamp. So please consider subscribing to MLExpert Pro. Thank you. I'm going to create a new directory for our project, and I'm going to call it bodyfat. And once this is added, I'm going to enter the directory and I'm going to start Visual Studio Code within this directory. Within the VSCode instance, I'm going to create a new file called project.tomo, and within the file I'm going to specify everything that we are going to need in order to install the environment with Poetry. So I'm going to just copy and paste the contents of this, and I'm going to save this. So the most important parts here are the dependencies on Python. We are going to use NumPy, sklearn, XGBoost for our classifier or regressor, FastAPI for building our REST API, Unicorn to serve the REST app, Pedantic in order to validate the models. We're going to also be using DVC or data version control system, and pandas. And here in this group, we have dependencies that are going to be used only during the development of our project. We're going to be using rough for code formatting, and then PyArrow and FastParquet in order to save our database files or dataset files within the Parquet format. TKDM for progress bars, JupyterLab, Matplotlib, Seaborn, DVC Live for logging our experiments. YAML files, we're going to be working with those. We're going to create a parameters file, and then Python box in order to load the YAML files. On top of that, I'm going to also specify the VSCode directory right here. And here I'm going to create this file settings.json. So here, let me just format this correctly. I'm going to be using this should be right like that. Okay, so here I have formatting on safe, and I'm specifying the default formatter. Then I'm going to specify that on safe I want fix all and organize imports to be called. And once everything is complete, I'm going to essentially use the Poetry in order to install the dependencies that we've specified. And to do that, I'm going to specify that I want to use 3.11.8. And this version is coming from my PyEnv environment. So this is why I can use this version of Python. And you can see that this is actually creating a new virtual environment for us. It is under PyPoetry virtual env, and then it is actually calling this one. So everything appears to be working all right. Then I'm going to specify that I want to install all of the dependencies. After the installation of the dependencies is complete, you see that pretty much everything was installed for you. We have a lot of packages that have been installed and updated actually. So the next thing that Poetry said is that it cannot install the current project since the README file is missing. I've went to the VS Code and added an empty README file. And next, if you try to again install, you see that we don't have a package called bodyfat. So let's quickly fix this and try to install the project itself, or our project itself. I'm going to create this bodyfat directory, and other than that, I'm going to create a new directory called artifacts. Then I'm going to also create a new directory called bin. In here, we are essentially going to store our binary executables for our project. And within the artifacts, I'm going to essentially store some data. And in here, I'm going to also create another directory called raw. So in here, I'm going to add an SQLite database in a minute. And in the bodyfat, I'm going to actually create a new file called config.py. And in this file, we are essentially going to store the paths that we need in order to get the proper files within our project when we are building the dataset and when we are doing the feature building as well. So to do that, I'm going to get the configuration file. And here are the contents of it. It's actually pretty simple. So this is essentially going to create a directory or point to the current directory of the project up home. And within that, I'm going to create this artifact data, features, models, and experiments. So after restarting the VS Code, I was able to choose the correct environment. And after this is complete, you can see that the imports are now correctly imported from the libraries that we are going to be using. The first function from the config file is actually this word_config. This is essentially going to get this params.yaml file, which I'm going to create right now. And I'll explain the purpose of this file in a minute. And then we have this helper function called seed everything, which essentially going to be taking a seed from the params.yaml file and then seed the random number generator for the Python library random, and then for the NumPy random generator as well. So this is the config file, and for the params themselves, we're going to be getting essentially these parameters. So why I am splitting the config.py and the params YAML file? Well, the important part right here is that the params YAML file are going to be programmatically changed, can be programmatically changed via DVC, and the config file essentially has only the paths that we are going to be using. So the params themselves can be changed during, so for example, some hyperparameter tuning, but the config py is going to be essentially all constants. And these can be changed if you will. So the important part here is to create this init.py file. And here I'm going to start by adding this config that we have created. And we are going to essentially get from the config file, import the config, the what config, and then the seed everything. And in order to expose those, I'm going to create a constant called O. And this should, yeah, this should expose all of it. Yeah. So this will give us the ability to call the bodyfat dot. For example, import from bodyfat config, what config, and seed everything. So this should be a nice helper. And now, if we go to the poetry part and run poetry install again, let's see if we get the installation correctly this time. Yeah, so we correctly installed the bodyfat package now that we have the bodyfat folder within the project. Next, I'm going to initialize a Git repository for our project, and I'm going to start by adding a git ignore file. This will be pretty standard for a Python project, but I'm going to also include dstore files and mlruns, since those can be used by the DVC that we're going to initialize as well. So next, I'm going to call git init. Yeah, so yeah, we are on master branch. I'm going to commit everything for now. Next, I'm going to also initialize DVC. So I'm going to enter the virtual environment using Poetry shell. And this will essentially activate our virtual environment. And here I'm going to just say DVC init. So this is going to initialize the repository with DVC support. And after this is complete, I'm going to add our first remote where our files are going to be stored. And in our case, I'm going to be using just a local folder, but of course you can use something like S3 or Google Storage, etc. These are all supported by DVC. So in the real world, you will probably do that. But here for the demonstration of this tutorial, I'm going to be using just a local directory, and I'm going to put everything into temp DVC store. Yeah, so if I run DVC status, there need no data or pipeline struct in this project yet. Okay, so DVC is now up and running for us. The last thing that I'm going to do is to create this dvc.yaml file. And we are essentially going to be adding some stages right here. And I'm going to start with the stage of build dataset. So for this, I'm going to ignore this. I'm going to essentially create a dataset within the bodyfat. So here I'm going to create this data folder, and in here I'm going to create dataset.py. Let me save this for now. And here I'm going to create a data class that I'm going to call just dataset. And the purpose of this class will be to read some Parquet files for features and labels, and then create this data class from that. Features, which is going to be a pandas data frame, and labels, which is going to be a series or pandas series. And then we'll have this instance or method for the data class, which we are going to just call write. And we are going to be essentially writing the features and the labels to the given paths. So this is pretty much the job of this dataset, essentially a data class that is going to hold the data for us. And then within the data folder, we are going to create this dataset builder.py. And this one is going to be a bit more involved. This is going to take or build for us this dataset builder class. And this will essentially do a couple of things for us. It's going to be loading a SQL database from a given path. Then it's going to be do some pre-processing for us, and then it's going to be splitting the data into training and test sets. And then finally, it is actually going to save the subsets for the train and the test sets. So I'm not going to focus a lot on the code right here. You can follow the tutorial for the specific code, but here you can see the organization of the files. And for the build, we have the read SQL, which is going to be essentially reading from this path or SQLite database. We're going to read pretty much everything from that. Then we're going to be dropping the original column, and then we're going to essentially rename every column to snake case. And after that, I'm going to essentially get everything except for the body fat, put it into an X. So this X is going to be in the train test split. And for the labels, we are going to essentially get just the body fat. And we're going to split everything and stratify on the sex of the users. And we are going to be using the data test size from the params. So this is coming from here. You can see that the data test size, we are using 20% of the data for test set. And then we are going to create this output directory. And then we're going to save the features into X subset parquet file. And then the labels, we're going to essentially give them to, again, a parquet file. But first, we're going to convert them into a data frame. So it is a bit easier to save those. So the next part of this will be essentially the script, which I'm going to create within the bin directory. And this will be called build dataset. And this script is going to be essentially a Python file, which is going to be extremely simple. Let me close this. So this will read the Python file for us and make it a bit colorful. So another important thing that we need to do for this to work would be to export the dataset builder from the body fat, since you can see that the config and seed, everything are actually very well imported here, but the dataset builder cannot be found. And for this, I'm going to essentially create an init file within the data folder. And here I'm going to essentially export the dataset and the dataset builder, just like I've shown you a couple of seconds ago on the root directory. Next, we need to add the dataset files in the init file at the root directory. The dataset and the dataset builder. So once those are here, we can essentially go back to the build dataset, and you see that the imports are now correctly edited right here. So the final part of this would be to go to the DVC YAML file, and we're going to go to the stages. for a command, I'm going to specify bin build dataset. And for the dependencies, I'm going to specify the artifacts raw data, which is going to be just the artifacts data raw. Copilot is not that helpful right here. And again, the build dataset script itself. For the output, we are going to specify artifacts data processed. And for params, we are going to specify the data file, the data part of the params.yaml. This one right here. So I've added the bodyfat.sqlite file, and now we can essentially do DVC repro to reproduce the build dataset. Yeah, I need to add the execution part to this. Let's rerun this. And you see that DVC is actually running this stage. It is calling the build dataset. And now that the stage is complete, we can go to the project, and you see that within the artifact data, we have the processed labels and features all in Parquet files. And as you can see, those were successfully ignored since those are produced by the essentially by our own pipeline. And in order to finish this, we are going to be pushing the pipeline, and this is essentially adding those Parquet files to our repository. So next, we are going to continue with building the features. And for that, I'm going to create a new directory in the bodyfat project or folder. I'm going to call this features. And here I'm going to create a features builder .py, and then init.py file. Again, very similar to what we have before. And for the features builder, I'm going to be using essentially one hot encoder, standard scaler, and then a column transformer. We are going to be having this single class, which is going to be taking the training data, the test data, the features directory, and then the models directory, which we are going to essentially output our preprocessor for the data. And the more important stuff here is that we are loading the config, and we are going to essentially get the numerical features and the categorical features from our dataset. And in our case, these are going to be, let me just show you from the params.yaml file. Here are the features. We have age, hip, abdomen, these new features that we're going to create. And then for the categorical features, we only have sex. Then we are going to create this column transformer, which is going to apply standard scaler to all numerical features, and then one hot encoding to everything within the categorical features. So within here, I'm going to next create this single method called build. And within this method, we are going to be essentially call the preprocessing of the data. And then we're going to save the features and the preprocessor itself. So for the reading, we are just going to be reading the features. Then we are going to create the new features, which are going to be a BMI, and then hip to height ratio, and then abdomen or waist to hip ratio as well. So these are essentially features that are going to augment our predictive power for our model in order to better try to predict the body fat percentages. And then we are going to create this features directory within the artifacts. And then we are going to essentially do train and test features within Parquet files. And then from the models directory, we are going to create this preprocessor joblib file, which is going to be essentially our column transformer that we have created here. So this is a lot of code, but it's pretty simple once you understand what is happening within here. Next, I'm going to essentially do the initializer from here. I'm going to be using the features builder, and I'm going to export this correctly. All right. Yeah, autopilot is really helpful here. And then here from features import, let's see, yeah, features builder right here. Yeah, and the auto formatter features builder. Huh. Did I? Yeah, this should be feature builder. All right. Maybe I wrote this incorrectly, but let's leave it as is. And then I'm going to create this build features script. This is going to read the train and test features, and it's going to output our features and then the model within the models directory. And it's going to be using the processed files from the artifacts processed files right here. So I think this should be it for this file. Then we need to add another stage to our project, and this is going to be called build features. The command will be bin build features. The dependencies for this one are going to be the process data and the build features script, which is correct right here. And the outs are going to be essentially artifacts features. Yeah, that's correct as well. And now let me clear this. Let's run this to be executable. Build features. And again, I'm going to do DVC reproduce the build features stage. Features, yeah, that's correct. So you can see that the build dataset stage hasn't been changed and it is skipped. So this is essentially going to apply only the new stage, which is going to be the build feature stage. And this will essentially push the data through our repository. Let's have a look at the artifacts. Now we have these features, which are both Parquet files, and then we have the preprocessor, which essentially is going to be our preprocessor. So everything appears to be running very, very, very smoothly. But one important thing that we need to do here is to essentially add this preprocessor to our project as a separate DVC file, since we are going to be using this into our deployment. And in order to do that, I'm going to be calling DVC add artifacts models preprocessor joblib. So this, yeah, this should push it. And now you see that we have this DVC file and we have this preprocessor. So in our case, let me just do this at stages. Yeah. So you see that the preprocessor here works as expected. And of course, one thing that we can do is to actually add to the git ignore right here. Yeah, this will be added to the git ignore, so this will not be tracked, which is correct. And then we have this DVC file, which we are going to be using if and when we want this model. So for the next part, we are getting the models folder. And here I'm going to create a single file called trainer.py. Again, an init file, which we're going to fill in a second. So now we have the building of the dataset and the features themselves. Finally, I'm going to show you how you can actually train the model with those. And here, instead of a class, we have two functions. The main one will be this train model, which is essentially going to be creating a model for us. Then we are going to get train features and labels. We are going to evaluate using this evaluate function, which is essentially going to get the predictions of our model and create or calculate the root mean squared error and the R2 score. So this is pretty much the way that we are going to evaluate this. And then using DVC live, which is extension of DVC, you can essentially track the metrics right here. And then we're going to save the model to the models directory model.json. And in order this to run, we are going to be importing from trainer import train model. Okay. Let's keep the syntax the same. And then here from models import train model. Okay, this appears to be looking good. And then we have this train model script right here. Let's paste in the code and open it up again. So what is happening here? We are using our helper dataset class. We are reading the features and the labels from the different directories, and then we are training the model with the train dataset and test dataset, a pretty simple script. So for the stage itself, we are going to be adding the new stage, which is going to be called again train model. Let's see. Train model. This appears to be looking very nice. Data processed, then artifacts features, bin train model artifacts model. These are the outputs. Not really. And for the parameters, we're going to be using the model itself. Let's try to run this stage. First, make it executable and then run DVC repro train model. Again, this is skipping the previous two stages. And this is actually saying that this is not going to be working as expected since we are running DVC repro, and DVC live is how we should run this, but that's all right. So this appears to be working. Now let's save our progress. Train model. And then I'm going to run DVC push. Okay, so one important feature of DVC is that you can actually run experiments. And in our case, if we do this again, you see that the current experiment has these parameters. And if we go a bit into the params, you see that we have the number of estimators equal to 10 and the warning rate 0.05. So what if I want to run another experiment with different hyperparameters? I can do that with experiment run and estimators for the model, specify 30. And for the warning rate equal to 0.1. Let's run this. So this is smart enough to know that the build dataset and build features hasn't changed. And if I run this experiment show again, you now will see essentially the difference between the validation and training metrics. So you see that we actually now have a much better model, which smaller error and a larger R squared with these parameters. So in order to add this, okay, so this will essentially save the model, the parameters, and we are going to push everything again with DVC. All right, so we are essentially going to do the same thing for the model as we did for the preprocessor. You're going to add it into a JSON file. Okay, so this is saying that this has been cached, which is correct. Okay. Okay, so this will add it for us. Track model. Okay. So the final part of our project will be to add file for the REST API. And this will be a rather simple one. So this is essentially a FastAPI app, which is going to be calling the preprocessor and then the regressor. It's going to load those, create a FastAPI. We are going to have a body prediction request. And this is going to essentially provide us with a body fat prediction based on the input of the data. This is going to essentially apply the transformations. Yeah, this appears to be working all right. And then I'm going to be running this. And what I forgot to do was to export the create new features from the features. So I'm going to fix this. Create new features. Okay. So now this should be fixed. And yeah, if we run this again, this should load the app. And here we have the REST API running within the browser with documents. And let's try the API. We get 11% for a body of a male with the height of 1.75 centimeters or 1.75 meters, weight of 70 kilos. Let's try to increase the abdomen to, let's say, 75 and increase the weight to 78. Yeah, this body fat got bumped up. And if we change this to a female, yeah, we will get a much higher body fat. This is expected. So it appears to be doing some sort of predictions. But yeah, the most important part is to know how to structure the project, not the accuracy of this model itself. So this is it for this video. You've learned how you can structure your machine learning project and use tools such as Poetry and DVC in order to make it a bit more reproducible and manage your dependencies much more easily. We've seen how you can use DVC Live to track some experiments and do even some hyperparameter tuning. Also, you've seen how you can wrap everything within a REST API. And all of this we've done using Visual Studio Code, so you can essentially structure your project as the way that I've shown you. Of course, this is one way to do this. And please let me know down in the comments below if you have other favorite tools that are essentially going to be making this project better, or maybe replace some of the tools. What are your favorite? Let me know. Thanks for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description, and I'll see you in the next one. Bye.